Hey everyone, I'm Abradip. I am a high schooler studying at Chittagong Grammar School at Bangladesh, Chittagong. I just gave my AS level exams and they went pretty good. And this channel will be to mostly help other students and like myself who are also struggling or have been struggling with their past paper solutions, and I would try to give solutions the way I did them during my examinations. And this is my very first video, so do give feedback, and yeah, I hope you find it useful. So today we will be doing the mechanics paper for February-March 2024. So let's start. So the first question is a kinematics question. The displacement of a particle at time t seconds after leaving a fixed point O is s meters. The diagram shows a displacement time graph which models the motion of the particle. The graph consists of 4 straight line segments. So I would just say a little bit here. So the gradient of a displacement time graph gives us the velocity. So if the gradient is constant, this means the velocity will be constant as well. So gradient constant, so velocity is also constant. Then let's read. The particle travels 50 meters in the first 10 seconds, then travels at 2 meters per second for a period of 10 seconds. The particle then comes to rest for a period of 20 seconds before returning to its starting point when t equals to 6. Is at this point the s equal to 0, and they've also said that the v is constant at this journey, at this segment of the journey, and at this segment it is v equal to 0. So find the velocity of the particle during the last 20 seconds of its motion. So to find the last velocity in the last 20 seconds, we need to find the displacement at this point. So we will just be labeling this as s. Once this is s, as I just mentioned here, velocity is the change in displacement or the change in time, which means the final displacement minus the initial displacement, which is 50, by 20 minus 10. This is given to us as 2 meters per second. Or by cross multiplying, we get 20 plus 50 to be 70 meters. That is the first important thing to write. Then at this very point, the s is 70 and this is s equal to 0. So we need to find again by the same formula of velocity equal to change in displacement by change in time. We get that 0 final minus initial by 60 minus 40, which is minus 3.5 meters per second. You can check with your calculators, but this is the answer. So the concept of gradient constant, so velocity is also constant, is mostly important for the next part where we have to sketch the velocity time graph. So let me first just draw the axis, my axis labelings and all, time, and this is velocity meters per second. So look, we also need one more information here, the velocity during the first 10 seconds, which is just 50 by 10, 5 meters per second. How I did that, 50 minus 0, 10 minus 0. We know the velocity at this point right in the previous question, so we know the velocity at all points. Let's just, this will be freehand plotting. You don't have to do scaling and all for this type of plottings. Examiners do not really tend to require this type of labelings for like counting 1 centimeter, 1 block. You don't need that. You can just do freehand labeling, and even here as well. You just have to show the values that you will be using in both of your axes. And now let's plot. As I said, velocity is constant means it will be just horizontal lines like this. At different points it will be just this kind of horizontal lines. So in the first 10 seconds it will be like this. In the um, next 10 seconds we have a speed of 2, so this will be like this. And look, at this point the velocity is 0, means it will be a horizontal line on the x-axis, which is the time axis. In an examination, just use HB pencil to just bold this parts like this. And the last 20 seconds we also know that it is minus 3.5 meter per second. So the second question, let's move on to the second question. A particle is projected vertically upwards from horizontal ground. The speed of the particle 2 seconds after it is projected is 5 meters per second. And now it is traveling downwards. Let's get an idea. So this is what is happening. This is the particle is projected upwards, and this is kind of the motion. Let me describe. So speed of the particle 2 seconds after it is projected is 5 meters per second. So after 2 seconds, when it is traveling down, if you consider this motion to be plus v, this motion will be minus v. So at this point it will be minus 5 meter per second. But since the initial projection was towards the top, the acceleration will be minus 10. So we can do the equation. We'll just do this equation. We also know the time. The time is 2 seconds given. So the final speed is minus 5, which is equal to u minus 10 into 2. Then finally it will be minus 5 plus 20, which is 15 meters per second. Let's move to part 2. Find the distance traveled by the particle between the two times at which its speed is 10 meters per second. Okay, so 2 times. So it was initially projected with a speed of 15 meters per second. It will face 2 times v equal to 0, where this is one time where the speed is this, and one time where the speed here is minus. So one time the speed will be initially 10 meters per second. Second time the speed will be finally 10 meters per second. So 2 10 meter per second speeds will be once at initial position and once at the final position. So now there might be a question. It was initially projected with 15 meters per second. So the speed decreased as it went up due to air resistance or friction. It decreased. Slowly the speed decreased to 10, and it will eventually also decrease to 0 as well. So that's what happened here. So let's do this now. We will actually use this distance. We will actually name this distance S1, this to be S2, and I think we can now do this, right? So we'll use this formula: v square equal to u square plus 2. Since we don't, time is unknown, so we won't use v equal to u plus 80. That's the only reason why not using it. So this will be, so first we'll use initial to be 0, initial to be 10 meters per second. So 0 squared equal to 10 squared minus 2 into 10 into s, or use our calculator. Distance should be 5 meter, s1. Again, using the same formula, this time the final velocity will be 10 and the initial will be 2 0 squared. This time it's coming downwards. Acceleration will be positive as it's coming towards the center of the earth. Therefore the s2 will be 5 meters. So total distance equal to 5 plus 5, which is 10 meters. I hope that was clear. So question number 3 now. A crate of mass 600 kg is being pulled up a line of greatest slope of a rough plane at a constant speed of 2 meters per second by a rope attached to a winch. The plane is inclined at an angle of 30 degrees to the horizontal and the rope is parallel to the plane. The winch is working at a constant rate of 8 kilowatts. This is your basic diagram actually. Always draw a diagram of this type. This should be your constant diagram. Like, you will just edit around the number of objects or the types of force, just draw it, annotate it around this, but this should be your base diagram. So this is that, this is the winch. The winch is pulling it. There will be two components downwards. There will be one component downward. This is the weight, and this is the cost component of the weight, which is also equivalent to the R. And pulled up a line of greatest slope. So there will be, is there any friction? Yes, there is friction. So there will be friction, and another thing would be the 6,000 sine 30, and this will be 6,000 cos 30. I'm just doing the like component division, and this is the driving force. Since it's constant speed means the object is in equilibrium. I hope that would be clear. This is a common concept you need to know actually. So if we do it, 8,000, okay, let me just show you one more formula. Power is F by V, Fv, or F is power by velocity. So 8,000 by 2 is this is our driving force, right? So this is just side working. So this is that. It's equal to the friction. Also we need to know the friction is equal to mu R, from where we'll find the mu. So friction plus 6,000 sine 30, or mu R will be, let's just use the calculator here, 6,000 sine 30, which is 1,000. That is just an equation. So now we also have to do one more thing. We have to remove the R from here. So what is the R? It is, since it is in equilibrium, upward, downward forces are equal, right side, left side forces are also equal. So R equal to will be the cost component of the weight. Here what I'm actually doing is 600 into 10, which is mg. I'm just doing mg sine theta, right? I'm just doing mg sine, just so that you don't have a confusion. I just cleared that. Okay, so what's that? 152. So from 1 we have mu to be 1000 by 5196.152, which is 1000 divided by 5196.152, which is 0.192. I hope that is clear. Let's go to question number 4 now. So yeah, this is a coplanar forces question. So this is equilibrium. As you can see, the magnitudes are given, the direction of the forces are shown in the diagram because the forces are in equilibrium. So let's first do one thing, is that we have to divide in the components. The components have to be divided first before solving any of this type of questions. Let's draw the components. So for this one it is 30 sine theta, this is 30 cos theta, and for this one it is 2f sine 45, 2f cos 45. Now we will do x-axis, y-axis separation. For x-axis, 2f sine 45 plus 3f. I'm just writing the right side forces equal to the left side forces. That's all I'm doing, to 30 cos theta. So just use a value for 2 sine 45 and give it in terms of f. That is actually for simplifying the question. So it will be 4.414f to 30 cos theta. So don't actually simplify this. I will show you one trick regarding this. Wait a minute, I will be showing. Now let's divide the y-axis components. For y-axis, always use this type of like things in your examination, just to show a little formality so that the examiner understands what you're doing. Just this helps to like avoid any type of confusion, that's all. 2f cos 45 plus f is now 30 sine theta, or again 2 cos 45, put it in the calculator and add it with 1, so you get 2.414f. Okay, you don't particularly have to do it like this, simplifying like this, but I always did it. I felt like this helped me simplify my questions more or less, so I used to do it. You can try it out if is easy, or you can try out the method you are more comfortable with. Okay, so as I was saying, what we'll do now is, we know that sine theta by cos theta. There's a little bit of pure math knowledge for you. We know this. So if we divide these two equations, so 2 divide 1, what comes? It comes as 30 sine theta. 30. Just to find the theta, I'm just doing a simple technique, which I also like to do. Sorry. Yes. 1 minute. 4f by 4.414f. Now just cancel the f's, the 30s, or tan theta. Okay, just do it together. Theta equal to tan inverse of 2.414 by 4.414 equal to, or theta equal to tan inverse 2.414 divided 4.414, which is finally 28.67 degrees. Okay, we'll move on. Now we'll just use this to find the value of f. We already did theta, now we'll find the value of f. Just use one of the equations made before to find this. Let's say 4.41 for f equal to 30 cos 28.67. Just divide it, you should get f. Use your calculator. You don't have to write this like most of the times. I don't write them. I've never really lost many marks, honestly. So just do it in the calculator, saves a lot of time. So we have found both the theta and the forces. Time for question 5. Okay, a kinematics question related with differentiation now. A particle moves in a straight line starting from a point O, right? The velocity v is given with this equation of the particle. T seconds after leaving O is given by this. You may assume that the velocity of the particle is positive for this time, is 0 at this time, and is negative for all the values after this. Okay, find the distance between these times. Alright, let's begin. So we know that displacement is the integration of dt's. Okay, many of us tend to skip this particular line. Don't do it. The examiner needs to see what is the operation you're carrying out. The examiner might mistake it that you carried out differentiation for integration. It's not his fault or her fault. The examiner might think something like this. So always write this line. Let's continue. T cubed minus 4.5 t squared plus 1 dt. We'll integrate this t to the power 4. Actually, you can also put the limits together because we have to find the distance. Just let's place the limits, 0.5 and 0. 0.5 and 0. We'll just use the limits together. So we just don't have to include that c. We just don't have to include this. We just don't have to include the c. So minus 4.5 t cubed by 3 plus t, and this is for this amount of time. So let's see. You can either show the placement of the limits or just show the calculated value of each of the limits, which I will just show what I mean. I will just put the limits in my calculator. Let's do it. And plus 0.5. We did that. So it's 2164 minus, since okay, it will just be 0. It's in the end 21 by 64 meters. So that is your first answer. Let's go to part B. I hope this was clear. Find the positive values of t at which the acceleration is 0, hence find the total distance traveled between them. Okay, right. So as you can see in the question, we need to find the acceleration. Now again, we will shoot this line is dv over dt, which is d by dt of t, t cubed minus 4.5 t squared plus 1, which is 3t squared minus 9t. That's the acceleration. Now a equal to 0, as they said, find the positive value. We have to find the positive value when acceleration is 0 equal to 0. So 3t squared minus 9t equal to 0. Just take the t common, so it's 3t minus 9 to 0. Therefore t equal to 0, not applicable, as they mentioned. Odd, t equal to 9 over 3, which is 3. So right, now we have to use this. Let me show you one diagram first. So it starts from here, the object at t equal to 0 seconds, comes to 0.5 seconds and travels till 3 seconds. So in the differentiation or like calculus kinematics questions, always remember one fact, that whenever in this type of questions you have to calculate the displacement between 2 points, you always have to see if the particle or the object or the vehicle came to rest at any point within those 2 points. Here it did. For this type of questions, the common and the best way to solve it is find two distances, S1, S2. So here we have already found S1, as found in part A, right? Something like this, part A, right? S1 equal to 21 by 64. I have just mentioned that. Now S at this limits we have to find, which is S2. Let's see the equation. T to the power 4 by 4 minus, so as I told at the start, I am going to give you the solutions which I always use. Actually, knowing another student's way of solution is really helpful. I felt it, so I feel like you people will also be benefited. Use the calculator again. 3 to the power 4 by 4 minus 4.5 into 3 to the power 3 by 3 plus 3 minus 69 over 4 minus. I will also show you one more thing here. We find this. Now, will you keep a distance? Since at the end of the day it has asked for distance, you don't have to look at the sign. No need to look at the sign. So just keep it in, bring it in modulus brackets, and you should have that. Finally, total distance equal to 1125 by 64 plus 21 by 64, which is 21 divided by 64 is 5. Which is 573 by 32 meters. So yes, they'll ask for the total distance, and that is the total distance. Question 5 now. Question 6 now. A car of mass 1800 kg is towing a trailer of mass 300 kg. So okay, before reading the entire question, let's just draw our basic diagram again. As an angle is given, means it is going up at a slope, so we'll just draw our basic diagram. So yes, we have drawn our basic diagram. Okay, a car of mass 1800 kg is towing a trailer of mass 300 kg up a straight road inclined at an angle alpha. This is alpha. This is one object, the trailer, right? That's the trailer, that's the car. There is tension down this. Okay, so it's been pulled in that direction. Current trailer connected by tow bar, which is slight and rigid and is parallel to the road. There is a resistive force of 800 newton acting on the car. So 800 newtons down that slope, and a resistance force of F newton. Where's the F newton? So there will be also the components of the weight acting downwards, which I'm not showing in the diagram, but I will be showing during my write-up. So okay, find the acceleration means not in this. Whenever you see a question asking for the acceleration, it means not in equilibrium. Use F equal to ma. F equal to ma, and let's begin then. Driving force is 3000 newton. Okay. For car, 3000 minus tension minus 800 minus 1800 1800 into 10 to 0.0. This is the, I'm gonna be using the mg sine alpha, yeah, the downward component mg sine alpha. This will be equal to 1800 a. Let's simplify this. 3000 minus 800 minus 18 1 2 3 0.05. This is 1300 minus t. That's 1800 a. Equation 1 for Strehler. There are also tricks like to do the entire system in equilibrium, but I personally never use that trick or that method of solution. I felt this was easier. I think it's 5 marks. I can do this much working. Rather than doing a mistake trying to do of the composite system, I always did this way. If you people or any of you are comfortable with that way, you can definitely. So yes. Where was I? Tension minus, the F is given to us here at 100 minus the downward component, which is 300 into 10 into 0.05 to be 300a, or t minus 100 minus 3000 is 0.05, 250, which is 300a. This is this is equation 2. Now we'll do a little simplification or like elimination method. This one thing about the O levels really helps. This elimination method always has helped me to solve this type of questions. I think everything you ever learn is so valuable throughout your high school days and even in your universities when you go there. Okay, so we've added the equations and we find this, or the acceleration is 0.5 meter per second. I hope the simplification is understood. I've just added this equation, so but plus minus is always minus, so it got subtracted in this part. That is what it came. Okay, we just found the acceleration. We also need the tension in the tow bar. Let's find the tension now. Tension is 300 into 0.5 plus 250, which should give you 250 400 newtons. I hope that is clear. Let's move to part B. I hope that is clear. Part B, energy method. It is given instead the total work against friction in moving a distance of 50 meter is this. Speed of the car at, okay, so energy equation. Let me show how you can form an energy equation. So there was a driving force, isn't that? 3000 into 50 plus half 1800. So whenever you're calculating the final speed or initial speed using the energy method, and it's a combined particle question, and it's related to a combined particle question, you always have to remember that the mass will be a total mass. Total mass here is, total mass is 2100, which I've just written, and initial speed is 20, so half mv square. So we're using this formulas, square and mg sine theta h. These are the formulas we will be using here. Okay, this will be converted to 800 into 50. Why 800 is this force. This force is also like taking up energy after the conversion. Here in this type of questions, you will also write one thing: energy before you go to energy after. You don't have to like divide them into different portions. Initial kinetic energy, initial driving force energy. You don't have to do it. I never did that, and you also don't have to do it. Okay, so plus, where were we? Yes, the total mass into 10 into 0.05 into 50, and we also have a 6000. So we need to find V, which is final speed. So plus half into total mass. I'm just not showing the division again of the separate masses. I'm just showing together. Half mv squared or 1050 v squared. Just take all of these things to the left hand side and subtract from this parts. Into 50 plus 0.5 into 2100 into 20 minus 6000 minus 800 into 50 minus 2100 into 10 into 0.05 into 50 471500. This is a calculated value, of course, calculated value, and finally v is root over 71500 by 1050, which is in the end root over 71500 divided by 1050, which is 21.19 second or 1.2 meters per second. So we have found the value of the speed at the end of the 50 meters. So everything we have done in this paper till this very moment were just like 38 marks. And what Cambridge does so well is they will give you very easy till your 40 marks, and they will set one question. It could be in the middle, it could be at the very start, which is rare, or at the very end. This has been their new pattern. So they will set one such question, and this question right here in the paper or your iPad or tab, wherever you're doing, just give as many stars to the sum as you can. You have to revise this question. It's a very important sum. Cambridge has been setting quite a lot of sums in your AS levels of this type. I've seen quite a few whilst my preparations, and there is a common strategy. Because look, once you've built on those concepts, the formulas, the concepts, the methods, you've learned them all and they're clear in your head. But after that, it all comes down to the strategy or the easiest method you use in your examinations. That is something what we will be trying to do here. Let's read the question first. Diagram shows two particles P and Q which lie on a line of greatest slope of a plane ABC. Particles P and Q are each of mass m kg. This is m, this is m. The plane is inclined at an angle theta. You can see the theta. The horizontal where sine theta. Okay, I'll just show you one trick here because you will be needing the value of the cos. So this is something you have to just do it at the very start itself. So like since sine okay, let's first show the theta. So 6 by 10, which is 3 over 5. What I did right here is 0.6 is 6 by 10. We know that 6 by 10 is 0.6, and if you simplify 6 by 10, it gives you 3 by 5, which is also 0.6. So that means your opposite and hypo are found. You have the, and in triangles where one side is 3, one side is 5, anyway it could be, this is like a common thing, we have seen it many times. So that is what I just did. So this is 4, and cos theta is 0.8, like 4 over 5 and 0.8. The length of AB is 0.75. We can see that. We can see also this distance, and length of BC is this. The section AB is smooth. Important. Very, very important information. And this one information sets the sums, all the tricks in this one sum. Rough and smooth. So the coefficient of friction each particle. Okay. So whatever the particle in this section, mu is 0.25. Mu is 0.25. Particle P is released from rest at A. At the same instant, particle Q is released from rest at B. So what they meant is they are released together. That is at the same time. Please write these side notes that I gave you, because they are the things that whilst you revision the same sums, you will need them. And one thing is, in maths, it's not about memorizing the sum. In revisions, you typically do not memorize sums. Rather, you memorize the techniques, like a plus b whole square is a square plus 2ab plus b square. Like, that's a formula you learn that you have to learn. But you cannot learn values, because Cambridge, at least in mathematics, gives all the repeating concepts every year, but rarely gives you repeated questions like direct values, direct answers. That's rare, but they do give concepts to be repeating. Okay, so verify the particle P reaches B 0.5 seconds after it is released with speed 3 meter per second. So let's find out the acceleration in the plane AB, which is m a equal to, so since it is smooth, there is no friction, it's just the downward component 0.6, which is mg, the sine theta value I just used it directly. Got the m, and the acceleration is 6. Now to find the speed, we equal to u plus at after 0.5 seconds. So we equal to, initial speed is 0 as it is from rest, as it is mentioned from rest, plus 6 into 0.5, which is 3 meters per second. So that was that. Now let's move to part B. Okay. Find the time that it takes from the instant the two particles are released until they coalesce or collide. Now, the trick is in this part, mainly in part B. So the first thing is first, we found the acceleration in the plane AB. Now we also need to find the acceleration in the plane BC. There are different planes, so acceleration of the particle, both will have the same acceleration, but it will be different in both the sections. But same for both the particles in each section. If Q was to be in plane AB, it would have an acceleration of 6 as well, as their same mass, so their pulling force towards the center is the same. That is the acceleration, F equal to ma. So acceleration at BC, we'll do this now. What are the informations we have? ma, this, and the resultant force. Here you have to find the resultant force. It's moving downwards, means first you have to write 6 into 0.6 into 10 minus the mu r. Now let's write the r here, the r over here. Sorry. R is your equal to the cos component of the weight. For just find out for one, it's the same for both. So, and we're just finding the acceleration of one particle, of each particle in the plane BC. So the R will be, that's why I actually told you that the cos component is required. So m into 10 into 0.8 . So where were we? You're somewhere here, right? I lost it. Okay, into 0.25. Yeah, that is something I was actually searching. I lost the value of mu actually. I'm so sorry. So this 0.25 into 10 into 0.8 gives you 2m. I just placed it together. And okay, there is an m actually here too. Why it is mg sine theta. So just divide it by the m, or acceleration is 4 meters per second. I hope that made sense. The trick. So if you consider from point B, when you consider and write in the examination all that from point B, what we need to see is you have to consider t to be the time for any one of the particles. Most of the times we consider that to the particle that came to that point later on. So okay, let's first say one more thing. For the collision, their distances have to be same, isn't that? SP equal to SQ. Displacements or distances have to be same. So we will find SP, which is, for S, the initial speed was 3 into t plus half into 4 t squared, which is 3t plus 2t squared. Right. Now we'll go to SQ. There's the trick. when at the initial position they were both released at the same time, which means when at the time 0.5 seconds, when P was already traveling in the plane AB, Q had already traveled that much in the plane on the plane BC. So we have to consider that whilst moving in the plane BC, Q was always traveling 0.5 seconds extra, always, and P would have to cover or has to increase its speed or acceleration to its speed actually to that point where even after this early start for Q at this BC plane, it can catch it. That is why we have to do T plus 0.5 for Q. This is such a common trick. All types of question where both particles are released from the same point, and then we have to consider that they come to one like particular point and then again start from that point. You always have to consider a plus additional time that the first particle released from a higher position was released from. That time you have to consider. So we will write SQ. So it started at 0, like initial speed was 0, so plus half into 4, 2 t plus 0.5 whole square. Simplify this, 2t squared. So 2 into 2 into 0.5. I'm breaking down the things, plus 0.5. That is another one. So now SP equal to SQ, as I said, 3t squared plus 2t equal to 3t 3t plus 2t squared is equal to 2t squared plus 2t plus 0.5. So just cancel out both sides on this. So t would be 0.5. Now this is not the answer. Still there is one trick. This, up until this, you have received 3 marks right here, but you still have one more mark to acquire. Why this is not the answer is they said find the time that it takes from the instant the 2 particles are released. When the 2 particles were initially released, P was released from point A. So you have to at the end add the time 0.5 seconds with the time we just found here. We have to always add 0.5. So therefore total time is 0.5 plus 0.5, which is 1 second. That is the sum, and that gave you 4 marks. See, only 4 marks it may seem, but that is a lot of marks. And if you cannot do that part, you're automatically losing this 5 marks. And by practice, frequent practice, you have to know one thing, that you have to be able to solve this type of questions with good frequency. 5 questions you have to get 4 correct. Maybe one mistake, do one mistake sometimes, but frequency matters. Now, next part. The 2 particles, when they collide, the coefficient of friction between the combined particle and the plane is still 0.25. Find the time that it takes from the instant as particles collide until the combined particle reaches C. So we need to first see that what their speeds were before the collision. Before collision speeds. So for VP, initial speed was 3 plus 4 V equal to U plus 80. So 4 into half time is this, so this is 5 meters per second. VQ is 0 plus 4 into 1. Why 1? As it has traveled 0.5 seconds more. So see this, if you couldn't guess the trick in that previous part, it's impossible to get this part correct as well. So those are the speeds. Now we'll use m into 5, the collision theory, the conservation of momentum theory, plus 4m is 2m v, or just cancel the m's. V equal to 4.5 meter per second. Isn't that? This is the speed after collision. So now we have to find out distance remaining after collision to reach point C. To find this part out and to find initial speed for one, so 3 into plus 2 into 0.5 whole squared, 3 into 0.5 plus 3 into 0, 2 meters remaining distance equal to 3.25 minus 2. Wasn't that 3.25? Yes, 1.25 meter. I will proceed to my additional page. Do use it in the exam if you think you need it. So 1.25 equal to, the initial speed was 4.5 after the collision, t plus half into 4 t squared. Acceleration is same, acceleration cannot possibly change. Or just simplify it, 2t squared plus 4.5t minus 1.25 equal to 0. Or just now place it in the calculator, 2 4.5 minus 1.5. I hope you guys know that you can place your equations itself on the calculator. I hope you know it, that is important. So t equal to 0.25 and minus 2.5, sorry, this is or, never write this and. So minus 2.5, this is not applicable as t cannot always. One more thing is, I'm telling you from my experience, always describe this type of things. Why this t is not possible, why you won't be taking this particular velocity. Yeah. Therefore, the time equal to 0.25 seconds. So I hope you can see how many thought processes had to combine in this question, in question 7. So this is your entire paper. I hope you understood it, and this is like the entire paper. This is question 1, question 2, question 3, question 4, question 5, question 6, question 7. So that is how a Cambridge paper actually is. They will give one hard question. Whoever manages it gets those A stars, glory grades. Whoever doesn't, does not. So it's about practice. It's not impossible, definitely. And one more thing I want to tell is, if in an exam the scenarios like this is so hard that not a single student, or like not, let's say 100% of the students gave the exam, let's say 100% gave the exam, and only 10 to 15% managed this type of a question. Like, managements completed the entire part. Sometimes many students get the question but run out of time, because whilst thinking they have taken up enough time, because it's quite natural. So at that time, grade thresholds, like threshold decreases significantly. It's a very significant decrease if those type of scenarios are something that happens. So yeah, this is something just I'm saying outside the thing. So yeah, that is it about this paper. I hope to publish regularly, and my university applications are also very near, so I still will try to publish, to post regularly. And please give feedback in the comment section if this is any way useful to you, or what are the places where you wish improvement from my solutions. So that's all. Bye everyone.